Hello, everyone. Welcome to the next session. Really excited about this one. I think it's going to be an excellent conversation. So, Felix is going to present how a single machine project grew into a full IIoT platform, and obviously share how his team has connected the data from the workpiece all the way to the cloud using Node-RED, as well as FlowFuse. So, super excited. Felix, I pass you the mic to give a introduction of yourself as well as your team, and then get into the solution. Thank you so much. Really appreciate it.
Yeah, thank you very much for introducing me, and also huge thanks to FlowFuse and the OpenJS Foundation for making today's event possible. That's really great. So let me first briefly introduce myself. My name is Felix, and I've been with Walter Tools for over 8 years now. I'm responsible for all kinds of IIoT solutions, so connecting machines, providing data, machine data to MES and ERP, but also building automations and factory dashboards, so things like that. My journey with Node-RED, however, actually started long before we used it in the company. So it began at home around 7 or 8 years ago when I bought my first Raspberry Pi, and Node-RED was pre-installed and I was immediately hooked. I started experimenting with small personal projects like smart home automations, energy and solar monitoring, and also, yeah, all kinds of dashboards to bring everything together. So, yeah, what began as a simple hobby quickly became something I really enjoyed, and also something I couldn't stop exploring. So, um, later, I introduced Node-RED into our company and eventually FlowFuse as well. So today we are running more than 100 Node-RED instances in production, connecting over 100 machines across multiple factories and in multiple countries. So yeah, what began as a spare time curiosity has become a central part of how we build IoT solutions at scale. And yeah, today I'd like to show you one of the industrial projects that came out of this journey. So let me share my screen. Yeah, that being said, welcome everyone to my talk, which is from workpiece to cloud. Today, I don't just want to show you a technical solution. I want to take you on a short journey from a single machine project all the way to a full-scale IIoT setup powered by Node-RED. Yeah, I think we can skip this one. So let's jump into the topic. So a few years ago, a machine project kicked off our journey into IIoT. One production unit decided to invest in a fully automated, custom-built measuring machine. And that was the moment we started connecting machines, collecting data, and integrating it into our enterprise systems. So let's just have a short look at the machine, the workpieces, and the process. So on the bottom left, you can see an example image of our workpieces, which is a solid carbide insert. Our customers use these kinds of inserts for metal cutting, and during the production process, we have to measure several parameters, such as weight, geometry, but also material properties. The inserts are then placed on workpiece trays, and each tray is marked with a data matrix code that links the order ID to the workpiece tray. The trays are then fed into the machine where each workpiece is measured. So that's the simplified physical process. But there is also a digital process running alongside it, so supporting every step. The IT requirements for this digital process were quite straightforward. So we have to read an XML file, which we receive from the ERP, extract data out of this XML file. The data is, for example, the workpiece type, so that the machine knows how to pick the workpieces, target values, tolerances, and things like that. Then we have to send the data package to the machine, read the measurement results back from the machine, and export it back to the ERP again. Yeah, sounds simple on paper, right? But at that time, we had no IIoT platform and no internal setup to handle this kind of integrations. So we outsourced it to an external partner who built a tailored application that did exactly what was needed, but only for this one specific use case, basically a so-called point solution, great for that one job, but not flexible, not reusable, and not built in Node-RED. The point solution then kept running for a few years, stable, but without real evolution. So no new features, just small fixes. But as we all know, production doesn't stand still. So requirements changed and also new challenges appeared. So over time, the requirements kept growing, not only for the measuring machine, but across the entire production. All of a sudden, we needed like live dashboards showing machine data, but also capturing the data for in a historical database, also integrating the data into our MES, and even things like machine-to-machine communication. So it became obvious that our old point solution could never keep up. So we brought the whole IIoT topic in-house. And Node-RED became the heart of our IIoT environment. And with FlowFuse orchestrating everything, we scaled up to more than 100 instances across multiple plants, across multiple countries. So back to the measuring machine. At this point, we had an IIoT platform, but the measuring machine was still running on the old solution. So we had to make a decision, either extend the existing application or migrate to Node-RED. Extending the old solution would have added complexity, further increased third-party dependencies, and relied on legacy code that wasn't maintained. So even though it was working perfectly well. So migrating to Node-RED, on the other hand, offered flexibility, scalability, and used our internal know-how, but it was still unproven for us for this kind of scenario. So until now, we had always taken like a passive role by only reading data from machines. But in this use case, however, we would be taking a more active role by writing data directly into the machine. So at the end, the benefit clearly outweighed the risks. So we decided to take the Node-RED path and give it a try. So let's take a look at the Node-RED prototype and how we started building the solution step by step. We started by breaking down the old application into its main components and mapping each functionality directly to a Node-RED functionality or a Node-RED module. So, for example, the application had an operator UI, which we can replace with the FlowFuse Dashboard. So then the next functionality is importing data from ERP and exporting data to the ERP. This can be replaced by a read file node, a write file node combined with an XML parser. But we already planned at this stage to switch from a file-based interface to a REST-based interface. And for this, we can use the HTTP nodes. So this is also going to work. Then the last functionality is writing to the machine and reading from the machine. And this is handled or done via OPC-UA. And for this, we can use the OPC-UA node. So at this stage, we were quite sure that migrating to Node-RED is going to work. So in the next step, before building the prototype, we looked at the big picture. So which systems are involved, how they communicate, and at what point in the process. There are three main players, which is the ERP, Node-RED, and the machine, of course. So let's focus on the part Node-RED ERP first. It all starts with the ERP creating an order and sending it to Node-RED. And this usually happens a few days before the actual measurement. Node-RED then stores this data locally and keeping it ready for the process. Then, just right before the measurement begins, the operator scans the order number and the tray ID using the operator UI, which then creates a link between order and workpiece. And this information is also added to the Node-RED cache, which we use in this case SQLite for, in case someone is asking this question. Then the last step is the communication between the machine and Node-RED. And this starts by the operator loading the workpiece trays into the machine. And this can be one order, one tray, one order, multiple trays, or multiple orders and multiple trays. Anyways, the machine picks the first tray, scans the code, and this basically tells Node-RED, hey, I need target values and tolerances for workpiece tray XYZ. Node-RED then looks it up in the cache and sends the data back to the machine, which tells the machine, hey, workpiece tray XYZ is order ABC. Here is the data for it. The machine then starts measuring each workpiece and sends the result back to Node-RED again, which collects the results until the entire order is complete. So then the last step, exporting the data. Once an order is complete, Node-RED creates a final data package and sends it to the ERP, which is SAP in our case. This data package contains all measurements for this specific order. But there is a second stream. In parallel, a continuous live data stream is sent to the cloud, containing not only the measurements, but also additional information like machine states, error messages, so things like that. And this data is then logged in InfluxDB cloud and also used to build a Node-RED dashboard in the cloud for visualizing the machine data in real time. We are going to have a look at this dashboard later on. So now let's have a short look at the Node-RED instance running next to the machine. So this solution consists of multiple instances, but this one is the heart of everything. Running next to the machine. And it consists of multiple flows. So there is like an I/O flow handling the communication to SAP. So it's importing the data, then it's doing the XML parsing, extracting the values, and adding it to the cache, and also the exporting part, which is basically the other way around, so building the XML and sending it to SAP. Then there are, for example, database services. This is like a bundle of different SQL statements, which are then exposed via a link call. So in the entire Node-RED instance, there's only one flow containing SQL statements. And this is the way we build it to have it more manageable. Then there is the GUI and some initializing stuff. So that doesn't matter for today. The main part of the flow is the event reactor. So it's basically a subscription, an OPC-UA subscription, subscribing to the main 3 events of the machine, which is, hey, there is a new workpiece tray, there are new measurements available, and the workpiece tray is finished. So when there is a new workpiece tray, we jump into this section of the flow, and also it's quite simple. So this is again, this is the link call. So we put in the equipment tray, we get out the data and send it to the machine. Then there is the trigger whenever a new measurement is available on the machine. Then we jump into this section. So this triggers another OPC read. So we read the parameters and additional information, which is then combined into one data set. And this data set is, like I mentioned before, streamed directly to the cloud, but also added to the local cache. And then there is the last action, which is workpiece tray is finished. And this is also quite simple. So whenever this is triggered, we check, okay, is there another workpiece tray belonging to this order? If not, the order is complete. And this triggers the export, which is building the XML and sending it to SAP. Yeah, one thing to mention, this not always happens in sequence. So it's possible that everything runs simultaneously. So it can be there is going to be an import data set, but then the machine is importing a new workpiece tray as well, while still measuring on the old workpiece tray. So it's all kind of happening at the same time. All right, so now that we've seen the flow in detail, let's zoom out and take a look at the bigger picture. So this title, From Edge to Cloud, sums up the three main layers of our setup, which is the edge on the machine, IT for enterprise integration, and cloud for dashboards and long-term data. On the next slide, you see how these parts connect and where Node-RED sits in each layer. So this is simplified the overall architecture. Like I mentioned, we work in three layers, OT, IT, and cloud. And at the edge, right next to the machine, we run local Node-RED instance, which is, by the way, a FlowFuse device agent. And it handles the machine communication, the operator UI, and the temporary caching. And this ensures that the machine keeps running, even if anything upstream is slow or offline. Then there is the IT layer where we connect to SAP. So this one is a shared instance. It's shared across multiple processes, and it's a combination of file-based and REST-based interface to SAP. The important part here is, regardless of how the data enters our IIoT environment here, everything converges into MQTT. That means there is no direct connection or no direct communication between Node-RED instances at all. Everything is handled via MQTT. And then there is the cloud, where another Node-RED instance run in FlowFuse Cloud. And this is used for dashboards. It receives live data from the MQTT broker, but it's also used to pull data from InfluxDB Cloud for visualizing historical data. So in the end, instead of one monolithic solution like it was before, we now have a modular layered architecture with clear responsibilities and like simple building blocks, all based on Node-RED. So here is an example of our cloud dashboard, of one of our cloud dashboards. I recorded a short video, which I can show to you. While the video was captured in the live system, the data shown is masked. So for orientation on the top, you see like the live states of the machine, if it's measuring or not, if it's in auto mode, if there is a warning, or if there is an error. There's also like this little state trail showing the past 12 hours when the machine was active and when not. And below, we have the last received measurement from the machine with a timestamp, order ID, tray, and the measurements itself. The center part here is used for historical data, and we have a look at it right now. So we start by selecting a group of inserts that's like a family of similar inserts, and the selection acts as a pre-filter for the following dropdown. And then we can select a specific insert type. So not an order, it's the insert type we select here, which then requests the data from InfluxDB and visualizing the data in the chart in the middle. Each data point here is one insert. So the cool thing here is we can see if there is a trend over time. So as it's not order-based, we can compare different orders with each other and things like that. On the left-hand side, You also get some average values, so average weights, average measurements, and so on. Yeah, to summarize it, it's a combination of live machine state or live data coming from MQTT and historical data coming from InfluxDB. And then there is also the operator UI. So it's also quite simple. I recorded a video. So the operator uses a scanner for it. So the operator scans the workpiece tray, and then operator scans the order ID, click on mapping, and this adds the mapping to the cache. And that's basically it. It's that simple. We can also remove data from the cache as well. And the machine also removes data from the cache as soon as it's finished this workpiece tray. All right, then the takeaways. So in our setup, we now have clear separation or clear separated responsibilities between Edge, IT, and cloud, creating a transparency, flexibility, and a future-ready architecture. And what I personally learned from this project is that big goals can seem quite overwhelming, but breaking them into small, manageable steps makes all the difference. So every quick win keeps you motivated to build the next functionality into the solution. So my advice to you, don't be afraid to just try it out. So download Node-RED, it's free, it's simple to start, and it's incredibly powerful. So you don't need to have a perfect plan to start with. Start with a small project, get results, and grow from there. So
Awesome, Felix. Thank you so much. Really good presentation and breakdown of the solution. Truly appreciate it. As
thank
you can
you.
imagine, there's a lot of different questions. Again, I will do my best to bring in a curated few. If you have some questions for Felix that do not get answered, I would highly encourage you to reach out. Um, Very, I guess, brief one. What kind of hardware are you deploying this at the edge, right? Are you running this in IPCs? Is it dedicated servers? Like, what does it take to
Yeah,
deploy?
for this specific machine, it's still running on a server in OT network. However, we plan to switch it over to a RevPi from Kunbus because we are using it on other machines as well.
Mm,
Actually, the RevPi lays on my table and just waiting to be installed by me. So yeah, we use RevPis for
gotcha.
that. Yeah.
Awesome. How are you managing version control for the applications? Where are you storing backups? And also, is there a plan should something fail on the recovery side?
Yeah, this used to be a problem before we had FlowFuse. We backed everything up to Git, so we activated in Node-RED the Git plugin. However, when switching to FlowFuse, we are now keeping everything within FlowFuse. So the deployments, so we don't develop on the live system. So what I've shown you is basically, there's a development system for it and a productive system, and we use FlowFuse pipeline to deploy it to the productive system or to the productive edge device.
Awesome. I would even personally have more questions on that side, but I'm sure that would be a a very long conversation. So we'll save that. Let me ask you on who's managing the application development. Do you typically have people on the plant floor making certain changes or using internal or external integrators? How's the development managed?
Yeah, so it depends. More complicated project like this is handled by our internal team. So that's mainly me and maybe a colleague in the future. However, when it comes to dashboardings, this is, yeah, it depends. Sometimes done by our colleagues in the business, and that's really great because that makes life easier for us. We give them the data. We don't lock anything behind a wall, and then the business can build their own stuff and the way they want to have it.
Mhm.
Yeah.
Gotcha. There was a question around, more proprietary protocol nodes. So you've mentioned OPC-UA, and the OPC-UA foundation, as you know, is a little bit restrictive. Can you comment on, whether you needed to get some licenses or memberships for the foundation to use some of the solutions?
Um, sure, we had to basically pay the license for the machine to be able to use OPC-UA. This was, yeah, we had to pay that. However, on the Node-RED side, we just used the yeah the node
Gotcha.
OPC-UA node. Yeah.
Understood. In terms of access and password management, for the actual operator panels, right? So there was a question if you're using OpenID, is it fully open? Is there access, let's say, for an operator versus, a supervisor or a manager to look at certain set points? How do you manage that side of things?
Until now, it's so we thought about using passwords, but that was always like a bit of a problem. The way we do it, as it's running in the OT network, so the dashboard can only, or the operator UI can only be accessed from the PC, which is right next to the machine. So there is no other way to open the operator UI.
Gotcha. There was a question on selling management and presenting this business case, right? So you've mentioned that there was a fork, sort of like a two-path scenario for you. Is there any advice that you would give for someone who's interested in building out something like this, but is a little bit, I want to say, hesitant or unable maybe to present a business case? How would you deliver that message?
Yeah, this is actually also a problem we had. So it was like an undercover project because we didn't really plan it. So it was like, okay, let's just try it. And as soon as it's going to work, then we present it and show the management, okay, it's working. So we have a better solution for it. So I can't answer that one.
Gotcha. But I'm assuming it was on a smaller scope, maybe like a local deployment environment before you do the full like cloud integration, or was it the
That,
full
that
pipeline?
that's right. So migrating it, we started with with the least amount of functionality so that the machine is going to work, but we skipped the whole cloud stuff and it was just, okay, the machine has to run, everything else comes later.
Gotcha. There was a question on the ERP side, right? So you put in SAP, which again, I have personally dealt with, and I know how complicated it is to get into some of those APIs. Was there again any fees or development that you needed to overcome and challenges on that side, or was it relatively simple with the current nodes available to get into
We
like the
don't,
ERP systems?
yeah, we don't get access directly to the ERP. We do have SAP CPI, which is basically the integration software for SAP. So that's basically an HTTP endpoint which we can talk to, but then there was some development on the SAP side going on to making this data we need available via this endpoint. So, but that's not my topic. So,
Gotcha. Yeah,
yeah,
again, it's a challenge, I think, for many organizations.
true. Yeah.
Let me ask you, I guess, a last question before we move on to the next presentation. So the orchestration via FlowFuse. I believe that the community is just discovering that possibility. Could you comment on, I guess, how easy or how complicated it might be to manage all of these instances at scale for you? Were there any challenges in the project or interesting findings?
Um, we had challenges before using FlowFuse because
Oh,
keeping track of the settings files and that everything is secured and the password is set on the editor and so on. That was a problem. However, now using FlowFuse, that's not a topic anymore. So the only thing we have to do manually is installing the device agent, but that's not that big of a deal.
awesome. Thank you so much again. Really appreciate it. And
Thank you
encourage
very much.
everybody to join the next conversation. Thank you so much, Felix. Thank you.
Thank you. See you. Bye.